Hi everyone, so my name is Nurunida Natasha binti Ramli. Firstly, I will present to you our introductions. So today I want to talk about something we all experience every day, which is walking. So walking is considered as the most basic and simple mode of transportation, and generally a person who walks or not in or upon a motor vehicle or other vehicle is termed as a pedestrian. It might seem simple, but imagine our bustling city street. The safety of pedestrians traversing a bustling street has become a matter of increasing concern. Between rushing car, crowded sidewalk, and hidden danger, being a pedestrian can feel a bit scary. That's where the issue of pedestrian safety comes in. Unpredictable hazard, limited infrastructure, and our growing city populations create a real risk for people on foot. Think about it. Have you ever felt rushed to cross a busy intersection? But guess what? We as students, by using some cool stuff called spatial analysis and working together, we make our cities safer and more walkable for everyone. Next, I will present our problem statement. So, unforeseen hazard, inadequate infrastructure, and confusing signage with a complex whip. Leaving those on foot feeling vulnerable. Think about it. Uneven sidewalk, poorly lit crossing, and unclear traffic signal. This everyday hurdle can turn a simple walk into a risky endeavor. Traffic density roars around us, a constant reminder of the potential danger. Inadequate infrastructure, from missing sidewalk to poorly maintained crossing, leave us exposed. And when clear signage is absent, confusion reigns, leaving us unsure of where to go, how to cross, and how to stay safe. These challenges are not simply inconvenience. These are threat to our well-being. They force us to choose between speed and safety, between convenience and comfort. Next, I will present of our objective in this study. As you can see, our objective is clear, which is to address the critical issue of unsafe pedestrian road crossing for pedestrians in Kuala Lumpur. Achieving this ambitious goal requires a strategic approach, one that aligns with global aspirations and leverage innovations. Inspired by principle of continuous improvement, we propose a Kaizen-based approach. This means small, incremental step, data-driven decision, and constant calibrations. Now, I would like to introduce our methodology. So the first stage involved is observation as the starting point. So our group opted to carry out our observations during the morning peak hour, so typically from 7 a.m. to 9 a.m. And the reason for selecting this period is based on several factors, which is firstly, it's the start of the working day for many people, and in cities like Kuala Lumpur, where park can be expensive and traffic is often congested. So walking is a popular option. And the second is it also the start of the school day for students, and especially for younger kids. So walking to school is a common way to get there. And lastly, the weather in the morning is often cooler and more pleasant. And this makes walking more enjoyable than it would be later in the day when the sun is beating down. But then from 10 a.m. to 4 p.m., things start to quiet down. So this is considered the off-peak time for pedestrian activity. These are a few reasons why we have opted for this particular period. First, most people are now at work or school, so there naturally less foot traffic on the street, and the weather can get hotter in the afternoon. This makes walking less appealing for some people. Also, some people may be running errand during their lunch break, but this usually result in less foot traffic than the morning commute. So during the off-peak hour, our sidewalks are a bit emptier, but that doesn't mean they are deserted. There are still people walking around, enjoying the city, and going about their day. And lastly, I will present our study area selections. As you can see from the table, we are carefully analyze various potential study area. So after much deliberations, we narrowed our focus to two key locations, which is Jalan Tunku Abdul Rahman, as known as Jalan Tahap, and Jalan Raja Laut.
Okay, so for the data analysis, we are utilizing the data using GIS software, which is we are using the spatial analysis techniques. We have identified the hotspots of geowalking by mapping the occurrences, examining influential factors such as pedestrian volume and the presence of building entrance, and exploring the impact of external elements like signal timing and weather conditions.
So in the process of digitizing data for our project, we follow a systematic approach that involves several key steps. First and foremost, we retrieve the necessary data from a home data website that serves as a comprehensive repository of Malaysia geographical and informational data. Once we have downloaded the required data, we move on to the next step by opening ArchMap. Within the ArchMap, we proceed to add layer by selecting the data we obtained from the website. This integration of data allows us to visualize and manipulate geographical information effectively. Upon completing the previous step, the map of Malaysia is dynamically generated. To narrow down our focus, considering our specific case area is Kuala Lumpur, we initiate the process of zooming in and finding Kuala Lumpur on the map. This step is crucial in refining our datasets and ensuring that we are working with accurate and relevant information for our project.
Assalamualaikum and hi, my name is Najat binti Muhammad Nur Isham. So for the next step of digitizing of data is to choose select by attribute for Jalan Tuanku Abdul Rahman and Jalan Raja Laut. By doing this step, we can focus on our selected route so that it is easier to referring the image and map later. The picture shown after zoom in, we can see the highlighted road are indicate the Jalan Tuanku Abdul Rahman and Jalan Raja Laut. After that, we need to overlay the satellite image with existing layers. So for this, we use georeferencing, which is we will add links between the control points on the image and the corresponding points on other layers. Firstly, make the georeferencing toolbar visible and add control on satellite image and Kuala Lumpur layer. So we can see the final result of georeferencing in the picture shown.
Assalamualaikum. My name is Mizan Mardia binti Abdul Rahman. So I will continue on explaining about the methodology for the digitizing of data. After we do the georeferencing process, we will do the editing step. These steps are to focus more on the route that we want. This step will highlight the route of Jalan Tuanku Abdul Rahman and Jalan Raja Laut. So the step is by creating a new feature class in a personal geodatabase, and then we open UpMap, and from the UpMap from the georeferencing, we can click the editing button and start editing. This is the final result of digitizing the data. From the picture, we can see two pale lines with pink color. This pale line with pink color is the line that have been editing by clicking from point to point that we want. As for us, we do the Jalan Raja Laut and Jalan Tuanku Abdul Rahman. That's why it have two line. And how the line are bigger is because we thicken the thickness of the line.
In our analysis of pedestrian behavior at signalized mid-blocks in Kuala Lumpur, we observed a consistent high volume of pedestrians, particularly during the evening rush hours. Notably, there was a noticeable increase in jaywalking incidents during these peak periods, indicating a potential correlation between pedestrian density and unsafe crossing behavior. Further investigation revealed that the signal timing at these mid-blocks was insufficient, leading pedestrians to feel impatient and resort to jaywalking to expedite their crossing. And next, pedestrian behavior and crosswalk infrastructure were the main subjects of our locality evaluations. The condition of crosswalks varied across locations, with some lacking proper signage and pavement markings. Additionally, pedestrians exhibited a tendency to jaywalk when faced with faded or unclear crosswalk indications. Interestingly, areas with better infrastructure witnessed fewer instances of unsafe crossing, emphasizing the critical role that well-maintained crosswalks play in influencing pedestrian behavior. And lastly, jaywalking behavior was significantly influenced by proximity to important destinations. Our analysis showed that mid-blocks closer to popular destinations experienced higher incidence of jaywalking, suggesting that the current locations of signalized mid-blocks may not align with pedestrians' natural pathways. Moreover, our examination of public awareness programs indicate a need for improved education on the risks associated with jaywalking. Many pedestrians seem unaware of the potential dangers and consequences, indicating an opportunity for targeted awareness campaigns.
Okay, so for the problem solving, based on the analysis of the pedestrian behavior at signalized mid-block in Kuala Lumpur, we have identified a few solutions to overcome the problem, which is 8 solutions or solving. So the first one is signal timing adjustment. Second one, crosswalk infrastructure improvement, pedestrian education programs, proximity to destinations, enhanced public awareness programs, infrastructure standardization, monitoring and evaluation, and the last one is collaboration with authorities. And by addressing these issues through a comprehensive approach involving infrastructure improvement, public education, and collaboration with relevant authorities, it is possible to enhance pedestrian safety and reduce instances of the jaywalking at signalized mid-blocks in Kuala Lumpur.
In conclusion, This research conducted in Kuala Lumpur, Malaysia, aims to enhance environmental quality and road user satisfaction by addressing the issue of unsafe road pedestrians. By focusing on pedestrian safety, the study aligned with Sustainable Development Goals 11, promoting sustainable and safe urban communities. Employing a Kaizen approach ensure a systematic, collaborative, and continuous improvement process. Furthermore, the integration of geography information system technology can amplify the impact by providing spatial insight into high-risk pedestrian zone, aiding informed decision-making, and enabling target intervention for a more effective enhancement of road safety and overall environmental quality.